Hi, I'm going to explain to you 5.2 notes, standard form, and intercepts. The key vocabulary for this lesson is standard form of a linear equation and x-intercept. What is standard form? Standard form is an equation. It looks like this: ax plus by equals c. We can see x and y, which we are familiar with. We also see these other variables, a, b, c, but these simply represent any number. For example, a might be 2, b might be 8, and c might be 10. These just represent some number that we can see one example here. What you'll notice is that the variables x and y are on the same side of the equal sign. In this example, they're both on the left. That's important to notice about standard form, so let's write it down. X and y are on the same side of the equal sign. Okay. And remember, those variables here, a, b, and c, can be any number. Okay, let's talk about x-intercept. You might remember that x-intercept has other names as well. You might hear it as root, as a zero, or as a solution. All of these words, x-intercept, root, zero, solution, they all mean the same thing, which is two things. First, the place where y is equal to 0. And visually, if we look at a graph, the point where a graph crosses or touches the x-axis. Okay, so let's make a picture of that so we can understand it better. If I'm looking at the coordinate plane, I know my vertical number line, my vertical axis is the y, and my horizontal is the x. If I have a graph that passes through the x-axis at this point, again, that point where it touches or it crosses over the axis, that's going to be the x-intercept. And what you'll notice if we examine the ordered pair that represents that point, we can see that it's 2 on the right. That makes the x value 2. But because it's on the axis, it's not above, it's not below, that y value is 0. And that will always be true for the x-intercept. The y value is always equal to 0. And that's what we see in the definition here, the place where y equals 0. This number represents y. It is 0, so this is the x-intercept. Okay. So we can find the x-intercept on the graph, but sometimes we do not have a graph. So let's look below at some examples where we need to find the intercepts without a graph. Example 1, finding x and y intercepts from an equation. So that is algebraically, we're going to do some math to find the intercepts because we do not have a graph to see them. Okay. Let's start with the x-intercept. To find the x-intercept, plug in 0 for y. We just learned that the x-intercept will always have a y value of 0. So we will plug in 0 for y in our equation. Naturally, to find the y-intercept, it will be the opposite. Plug in 0 for x. Okay. Let's try example A. Find the x and y intercepts for each of the following equations. Okay. We'll start with the x-intercept. Again, the x-intercept is where y equals 0. So I'm going to make 2 sections on my paper. One for the x-intercept and one for the y-intercept. So if x-intercept is where y equals 0, then we're going to take this equation, and where I see y, I'm going to put in 0. So let's do that. I do not touch this part, this is the same. I'm only going to substitute y. And where I see it, I will put my 0. Okay. Now I'll do some calculations. 5y means 5 times y. If my y is 0, I'm going to multiply 5 times 0. 5 times 0, any number times 0, is simply 0. So this whole term cancels out, and what I have left is 2x equals 20. I'm not quite finished. I still need to find that x value. Right now I see what 2x is. I want to know only 1x. So to eliminate that coefficient, I'm simply going to divide by 2 on both sides. 2 divided by 2 is 1. So on this side I have 1x. And on the other side, 20 divided by 2 is 10. So that tells me my x-intercept is where x is 10 and y is 0. Okay. Now we're going to find the y-intercept. We're going to use the same strategy, but this time we will plug in 0 for x. So again, that y-intercept is where x is equal to 0. So I'm going to copy my equation, but this time I'm going to plug that 0 in for the x. So instead of x, I'm going to write 0, and everything else stays the same. Again, if I'm multiplying by 0, I get nothing. This term eliminates, and I'm left with 5y equals 20. I don't want 5y, I want only 1y. So I need to eliminate this coefficient by dividing. 5 divided by 5 is 1. And on the other side, 20 divided by 5 is 4. What does this mean? It means my y-intercept is the point where x is 0 and y is 4. Okay. I'm going to show you one more example, and then I encourage you to try the other problems on your own. Okay. So again, we have 2 things to find, the x-intercept and the y-intercept. So again, I'm going to make 2 separate sections on my paper so I can focus on one part at a time. Let's start with the x-intercept. X-intercept is where something equals 0. Where do I put the 0? The x or the y? Let me go back to my definition here. It says x-intercept plug in 0 for y. Okay, so I know I need to put y equal to 0. So as usual, I'm going to copy my equation, negative 7x plus 8y equals negative 70. And where I see that y, I'm going to put a 0. Okay, everything else stays the same, only my y becomes 0. Okay, once again, if I'm multiplying something by 0, I get nothing. That term eliminates. If this term is eliminated, I have only negative 7x on the left and negative 70 on the right. I'm almost finished. I want to eliminate this coefficient, so I need to divide. I'll do the same on both sides. Divide by negative 7, divide by negative 7. I get 1x is equal to positive 10. So what does this mean? This means my x-intercept is the point where x is equal to 10 and y is equal to 0. We'll use the same strategy from example A down here. Again, that y-intercept is where x is equal to 0. So that same equation, the same problem, negative 7x plus 8y equals negative 70, but now I need to substitute 0 for x. So I'll put my 0, and everything else is the same. Again, multiply by 0, it just cancels. And I'm left with 8y equals negative 70. I need to eliminate that coefficient, so I'll divide. 8 divided by 8 is 1. I get 1y equals negative 70 over 8. Now, this is not an integer number. If you're using a calculator, you'll probably see that it's some decimal number. Let's simplify it using some simple division. So remember, when we're simplifying fractions, we're looking for a common factor of the numerator and denominator. And what I notice is that I can divide both the numerator and denominator by 2. And if I divide them by the same number, then I'll get an equivalent ratio. Negative 70 divided by 2 is negative 35. 8 divided by 2 is 4. So that's a simplified fraction, no calculator needed. This tells me that my y-intercept is the point where x is equal to 0 and y is negative 35 fourths. Right. So I encourage you to use these two examples to help you do the got it questions. Okay. And check with your teacher to see if they're correct. Okay. So you can pause the video now and do these questions. Okay, when you're finished, I'm going to explain example 2. Example 2, finding the intercepts in order to graph a line. All right, this is looking very similar. It says to find the x-intercept, what number do we put for y? Remember, x-intercept is going to be a point where x is some number and y is 0. So that's what we'll plug in. y-intercept is some point with a particular y value, but an x value of, that's right, 0. So we're going to plug in 0 for x. The same thing that we did on this page, we're going to do over here as well. All right. So again, I'm going to make two spaces, one for my x-intercept and one for my y-intercept. Okay. So I'm going to use this equation here, which is x minus 2y equals negative 2. Remember, x-intercept has y equals 0, so let's put it in. I see a y, I'm going to change it to 0. X minus 2 times 0 equals negative 2. 2 times 0, 0. X minus 0, x. So that whole term disappears. I'm left with only x, and on the left, negative 2. So my x-intercept is the point where x is negative 2. And what was y? That's right, y was 0. Okay. My y-intercept, I'm going to put a 0 in, but this time it goes in for x. For the y-intercept, x is equal to 0. Again, I'm using the same equation. It's the same problem, but this time I'm substituting for x. So let's do that. If x is equal to 0, well, 0 represents nothing, so I might as well just eliminate it completely. And I see that negative 2y equals negative 2. Again, I don't like this coefficient. I want to know only what is y. So I'm going to eliminate that coefficient by dividing. Negative 2 divided by negative 2 is 1. And I see that 1y is equal to negative 2 divided by negative 2, which is simply 1. So that tells me why my y-intercept is the point where x is 0 and y is 1. Okay. So what do I have here? These numbers in parentheses, they represent points. The directions tell me to graph those points, and if I connect them, I'll see my line. So let's start with the x-intercept. It's x-intercept, so I know it's going to be on the x-axis. Where? Where x is negative 2. That's on the left here. So that's my x-intercept. We'll do the same for the y. This time I'm going to look vertically at my y-axis. And where is that point? At 1, which is right here. So your line's going to look something like this. Mine's a little imperfect. Okay. Okay, let's do the same thing here. I'm going to go a little quicker. Again, same process. I'm going to take my equation and I'm going to substitute. First, I'm going to change that y to 0. This will be my x-intercept. And I get 8x equals 24. I'll divide both sides by 8, and I get x equals 3. Remember, this is part of a point. The x value is 3. What was my y? Always 0. So my x-intercept always will have a y that's 0. Okay. And I'm going to find that x-intercept on the x-axis. So where is x equals 3? Over here on the right. Okay. Same problem, same equation. I'm going to copy it here, and this time I'm going to replace my x value with 0. Anything times 0 eliminates. I get 4y equals 24. I'll eliminate that coefficient by dividing, and I get y equals 6. Remember, this is part of an ordered pair. This is a y value, so it's going to go in the y position. My x, of course, was 0. So here we have y-intercept. X is 0, but on the y-axis, I'm at positive 6. So we can see these points, if I connect them, produce a line with a negative slope that passes through the y-axis at positive 6 and the x-axis at positive 3. All right. So same thing. I just did 2 examples for you. Use them to try the next problems on the next page. So very similar. You're going to find those intercepts, your ordered pairs, and you're going to graph them and connect them to get your line. Okay, almost finished. I have one more example for you, and then you can try some more examples in 5.2 classwork. Okay, let's look at example 3, rearranging linear equations. A, compare the 3 forms of linear equations. How will you be able to recognize them? Okay. So we've learned 3 different equations for our linear equations. The first one we learned was slope-intercept form, which is y equals mx plus b. The other form we learned was point-slope form, which is y minus y1 equals m, parentheses x minus x1, parentheses. Finally, today we learned about standard form, ax plus by equals c. So take a moment to make some observations. What is similar about these forms and what is different? Well, one thing I notice, if you're looking at the equal sign, in slope-intercept form, you'll notice that y is alone on one side. Or we can say y is by itself. It's alone. Okay. In point-slope form, I'm noticing these parentheses. Okay. And finally, what I notice in standard form is x and y, we are on the same side. Okay. And we're going to use these different forms in different situations, depending on the information that we have. So you'll notice for slope-intercept form, the 2 pieces of information are m and b, where m is slope and b is y-intercept. The information in point-slope form, yes, we have m, but we also have this point, which we'll call the point x, y. And m is usually the slope. So, depending on the information you have, you might want to use a different form. What we just saw with standard form is it's pretty easy to use it to find the x-intercept and y-intercept. Okay, so depending on your situation, depending on the information you need, you're going to use a different form. Let's look at some examples. What form are the linear equations below? Rearrange them so that they are in slope-intercept form. Slope-intercept form means y equals mx plus b. So that's what it wants for these equations. Before we do that, though, let's identify what form they are in now. Well, I'm noticing in example B, x and y are on the same side of the equal sign. They're together on the left. That tells me this is standard form. Okay. The same is true in example C. Again, x and y are on the same side on the left together. That means this equation is also standard form. But now we need to change it. The question is asking us to rearrange them so that they are in y equals mx plus b form. So what do I need to do? Well, I'm going to do something so that in the end, my y is alone on one side. My y is not alone right now, so I'm going to move some stuff to the other side. Let's start with the farthest term, 8x. I don't want it here, so I'm going to subtract it. Okay. 8x minus 8x, it disappears. I'm left on this side with negative 3y. Over here, I have a number and I have some x's. They are not like terms. This has an x, this does not have an x. So I cannot combine these. I'm simply going to write them separately. I have a negative 8x and a negative 60. Again, I cannot combine them. They're different terms. This has an x, this does not have an x. So I will simply write them separately with their corresponding signs. The negative 8x is negative, so it will keep its negative, and the 60 is also negative, so it will keep its negative. Okay. Now, I have this new equation, negative 3y equals negative 8x minus 60. Again, I don't want this coefficient. I want my y to be completely alone. So, just like we did in our two-step equations, if I want to eliminate a coefficient, I'm just going to divide. And I'll do the same thing on both sides. And what I'm going to do is I'm going to write it separately over here. Notice for each term in my expression, I'm going to divide by the same number, negative 3. And what happens? Well, negative 3 divided by negative 3 is 1. So I get 1y is equal to, we'll do this separately, negative negative cancels. Can I simplify 8/3? No, they do not have a common factor, so I'll just leave it as it is, 8/3 x. Negative negative, again, cancels to a positive. Can I divide 60 by 3? Yes, I can. 60 divided by 3 is simply 20. So, by moving some things around, by using my inverse operations, now I have rearranged my standard form equation into a y equals mx plus b equation, which we call slope-intercept form. Okay. Let's try another. Again, my goal is to get that y alone. Right now, I see an x, I see a 6. Let's move those things. We'll start with the x. Again, I don't want it on this side. I can simply subtract it. Can I combine these? No. This is an x. This is not an x. So we will write them separately. Negative x minus 42. Do I want 6y? Nope, I want only 1. So let's divide everything by 6. Negative x divided by 6. Well, that's 1x. It's invisible, but there is a 1 there. So I'm just going to write this a little differently. I'm going to say negative 1/6 x. And then this fraction here, I can simplify. 42 divided by 6 is simply 7. So my slope-intercept form is y equals negative 1/6x minus 7. Okay. 2 more examples, and then it's up to you to do the rest. Again, if you feel like you understand, go ahead and skip over to the classwork. But I will do 2 more examples. All right, let's check it out. Again, I want to identify what form is this equation in. That's right, x and y are in the same side, so this equation is also standard form. I want to change it to y-intercept form, or y equals mx plus b. Oh, excuse me, slope-intercept form. So this is my goal. I want the y on one side, which means I need to move some things around. Again, we'll start with the x. We'll subtract that whole x term from both sides. Again, I cannot combine these terms. One has a variable, the other does not, so I'm going to just keep them separate. The 56 is positive, so I'm going to write negative 7x plus 56. All right. I'm not quite done. I still have this negative that I need to eliminate. So I know that I have an invisible 1 here. I'm going to divide everything by negative 1. Okay. Well, negative 7 divided by negative 1 is simply 7, and 56 divided by negative 1 is simply negative 56. So my final equation is y equals 7x minus 56, which is in slope-intercept form. Okay, our last equation is a little different. Notice this looks very different from this. What is different? Well, this one has parentheses. So those parentheses tell me that this equation is written in point-slope form. We still need to change it to y-intercept. So my goal is the same. I still want that y alone on one side. Okay. Now, you might notice we need to move this 4, but before we do that, I want to address these parentheses. Remember, when we have parentheses, whatever coefficient is in front has to be applied to each term in the parentheses. So, before we start solving here, we need to distribute and simplify this side of the equation. Okay, so this side I'm not going to touch. I'm just going to bring everything down here, and I'm just going to focus on simplifying the right side. The parentheses mean distribute or multiply, so I'm going to multiply 1/3 first by the x, and that's just 1x. So anything times 1 is the same number, which means I'm going to get 1/3 x. And then I'm going to do the same with the 9. I'm going to multiply 1/3 times 9. Well, I'm going to do that over here. Remember, the 9 doesn't have a denominator. but we can make one with 1. Okay, so 1/3 times 9 is the same as 1/3 times 9 over 1. And what I notice, if I multiply each side across, I get 9 times 3, which we can simplify. What's 9 divided by 3? It's just 3. So when I take this coefficient and I multiply it by this term, 1/3 times 9, I simply get 3. Okay, so this side is nice and simplified. Now I can address this side. Again, I don't like this term here. Let's move it to the other side by adding. 4 minus 4 is 0. That term disappears, and I get only y. And on this side, notice my 4 does not have an x. So I can't add it to the x, but I can add it to this other number. So that's why I write it below. I'm going to add the 4 and the 3, and the x will stay the same. 3 plus 4 is 7. So my final equation is y equals 1/3 x plus 7. All right, I hope this video was helpful. Again, you are responsible for trying those other problems to check if it makes sense to you. If you have any questions, please ask your teacher. Thank you.